Alright, in the last lecture we have learned pre-order traversal in binary tree. Now in this lecture we are going to learn in-order traversal. So let's say we have a binary tree like this and we want to in-order traverse through it. Now as you remember in previous lecture, when we are traversing through this binary tree, we have said that pre-order traverser first visit the root node, then left subtree and then right subtree. But in case of in-order traversal, this is different. So here, first we are starting from the left subtree, then we are going to root node, then the right subtree. Now in this binary tree over here, the first thing that we are going to do, we are going to start with the left subtree, which is located in this over here. So then we are going to continue to the root node, which is N1. Then we are going to continue visiting all nodes of right subtree. Now when we look at the left subtree over here, we see that there is another left subtree inside this left subtree over here. So this means that we have to start with smaller left subtree in this case. So here, as you remember, as we mentioned before in our previous lecture, all subtrees will be treated with this algorithm over here. So for all subtree over here, we are going to visit left subtree, root node, then right subtree. So when we come to this small subtree over here, which is located at the left, so here as you can see, we have left child, right child and root node. So this means that the first node that we are going to visit is left child. So in this case the left child is N8. So here the first visit in case of in-order traversal will be the leftest child in our tree over here. Then after visiting the left child, we are going to visit the root of this smaller left subtree over here. So the root node of this smaller left subtree is N4. Then after visiting it, we are going to visit the right node of this smaller subtree. So in this case, the right node of this smaller subtree is N9. So the next node that we are going to visit is N9. Now, after finishing visiting all nodes of this left subtree over here, it means that we need to continue to the root node. So in this bigger left subtree over here, the root node is N2. So the next node that we are going to visit is N2. Now, after visiting N2, we have to visit the right subtree of this bigger left subtree, which is located in bigger yellow circle over here. So the right child of this left subtree is N5. So this means that the next node that I'm going to visit is N5. Now with this, we have successfully visited all nodes of this left subtree over here. So here, algorithm says that after visiting left subtree, we have to visit the root node. Now in this case, for this binary tree, the root node is N1. So this means that we are going to visit N1 in this case. So the next node that we are going to visit is N1. Now after finishing N1, we are going to continue to the right subtree. So our right subtree is located within this green circle over here. So here again, the same logic will be applicable. So here again, we are going to start visiting the left subtree. So in this case, in this smaller right subtree, the left child is N6. So this means that the next node that we are going to visit is N6. Now after visiting left child, in this case, so we are going to visit root node. So in this case, for this right subtree over here, root node is N3. So we are going to visit N3. Now after visiting N3, the last node that we are going to visit is the right child in this case. So the right child in this case is N7. So we are going to visit N7 in this case. Now with this, we have successfully looped through this binary tree using in-order traversal. Now if we combine all these steps together, with this arrow, we can see the order of the nodes that we are visiting. So we are starting from N8, N4, N9, N2, N5, N1, N6, N3, and at the end, N7 over here. So this arrow over here shows the order of visit in case of in-order traversal. So this is how we are traversing through a binary tree using in-order traversal. So here the main idea is first we have to visit the left subtree, then the root node, then the right subtree. Now based on this logic over here, we are going to create a method for in-order traversal in Java. So let's head over to Java. Now here, after pre-order traversal, we are going to create a new method which is responsible for in-order traversal. So I'm going to declare our method like this: void in-order. So this method also will take as a parameter binary node, because we are going to call this method with the root node. Then the first thing here also we are going to do, we are going to check that if the node is equal to null, in this case we are returning, because this is going to be a base case for our recursive calls over here. So we know that whenever we are calling the method recursively, so in this case we have to have a base condition, because otherwise we might loop into the infinite loop. So that's why, to prevent this case, we are going to put a base condition over here. Now our base condition will be like this: if node is equal to null, this means that in this case we don't have any children for this node over here, so we need to stop over here. So in this case we are going to return nothing. So we're just coming out of these recursive calls over here. Now As we said in our algorithm, the first thing that we are going to do, we are going to visit left subtree. So this means that the first thing that I'm going to do over here, I'm going to call this method recursively with the left subtree. So it's going to be like this, node.left. InOrder node.left. Now after calling this, we are going to visit the root node. So we know that to visit the root node, we are just going to visit the value of the node that we are receiving through this parameter. So in this case, I'm just going to copy this part of code from here, from pre-order traversal, and put it inside InOrder traversal. Now after visiting left node, we are visiting the root node, so I'm printing out the root node's value to the console. Then the last step is we have to visit the right subtree. So in this case, I'm just going to copy this code from here and put it over here. So in this case, I'm going to put right subtree. Now with this, we have successfully implemented our InOrder traversal. So basically what we are doing over here is first we are visiting left subtree, then root node, then right subtree. So we are calling this method recursively first for left, then for right. Now as you remember, in our previous lecture, we have created this tree that is shown in this picture over here like this. We have just manually created these nodes and we have linked them because we have not implemented insertion method. So that's why I have created this tree over here manually. Then we have run it for the pre-order traversal. Now instead of pre-order traversal, I'm going to call InOrder traversal to see how, in this case, how this method works. So this is the order that we have shown over here. In case of InOrder traversal, the order must be like this. So if I run our code, now you see that the output is like this. So this output is identical with the order that we shown in this picture over here. So first we are visiting the leftest child, which is N8, then N4, which is the root of the left small subtree, then N9, then it continues N2, N5, N1, N6, N3, and at the end we are visiting N7, which is the rightest deepest node in our case. So as you can see, our InOrder method works the way that we discussed before. So with this we have completed our method. Now let's see what's the time and space complexity for this method over here. Now as always, we are going to start from the first line of this method. So in the first line we are checking that if this node is null, then we are returning. So these two lines of code over here will take a one-time complexity. Then we are going to continue to call this method recursively for the left node. Now in this case, we have two children in our binary node. So that's why this recursive call over here will take n divided by 2 time complexity. Then we are going to continue to print the value of node to the console. So this line of code will take a one-time complexity. Now similarly, calling recursively this method with the right child will take n divided by 2 time complexity. Now if you combine all these complexities over here, we get n time complexity. Now one more time I want to mention over here that if you don't understand how we are finding the time complexity for recursive calls like this, I advise you to go back recursion section of this course, and there we have discussed these cases in details. So I'm not going to go to the details of such cases in this lecture over here. Now the space complexity is also n, because in this case, whenever we are calling a method recursively, we are inserting these nodes to the stack memory, because for the next run we have to remember the previous node. So that's why we are going to get the nodes from the stack memory. So this means that all these nodes over here will be inserted to stack memory. That's why the space complexity is n. Now with this we have come to the end of this lecture. So in this lecture we have discussed the logic behind the InOrder traversal, and we have implemented in practice using Java programming language. And then we have learned what is the time and space complexity for this InOrder traversal over here. So hopefully everything is clear about this lecture. So see you in the next lecture.